In the fourth capacity matrix, you're figuring out how long it would take your planet to travel all the way around your star if it were at the distance of your habitable zone. To do this, you need a couple pieces of information. You need the stellar mass of your star. If you haven't figured that out from the last matrix, you should use this link. You should use this link here to get there. And your habitable zone radius, both the inner and the outer. And those you gathered in your second capacity matrix. So in order to figure out the revolution rate of your star, or the orbital speed to begin with, you scroll down here to this task in the capacity matrix. Notice that it focuses on orbital speed, and it says both the inner and outer boundary. So to figure out orbital speed, we click on this link, and if you scroll down to where this page says orbital speed, so right here, there is an equation down here at the bottom. It says V equals SQRT times the square root of G times M divided by R. So G is something called the gravitational constant. I'll show you where you can find that in a moment. M is the mass of your star, that piece of evidence that you put down in the beginning. And the R, or the radius at which your planet travels around your star. And that's your Ri and your Ro from the second habitable, from the habitable zone matrix. We're going to take that information as well as this number G here, and we're going to put that into a notebook. So I have all of that right over here. Okay, so I have my inner boundary of my habitable zone, my outer boundary of my habitable zone, the mass of my star, and I have this G, which is called the gravitational constant. So, and then what I'm going to do is take that information and put it into this equation. So V equals the speed at which the planet is traveling. So we're going to ignore that for now and just start with an equal sign. Remember, SQRT stands for square root, so I'm going to draw a big square root symbol. And then inside of it, I'm going to write 3 numbers. And I'm going to focus on the numbers in this video and then talk about the units in another video. So I'm going to take this G, which is over here. I'm just going to copy that exactly. 3.964 times 10 to the negative 14. And unlike numbers that have positive 14 there, or a positive number there, which are really big, this is a really small number. I'm going to take that number and I'm going to multiply it by my mass, which is 9.5. And I'm going to take all of that and I'm going to divide it by my radius. I'm going to start with my habitable zone inner boundary, which is 100.8. So all I need to do to figure out this equation is take out my calculator and start typing the numbers in. So first I'm going to clear what I had before, and I'm going to put in 3.964. If you haven't learned this already, if you want to include scientific notation, that's the times 10 to the, on a calculator, you hit this EE button. Once you've hit the EE button, you put whatever's after the 10. So in this case, it's a negative 14. So I'm going to type in 14 and then make sure I change it to negative. And if I hit equals, it does 2 things. One, it moves the decimal point, those 14 spaces. So the decimal point used to be, the decimal point here used to be here, and it just moved it, the 14, over to there. So all I need to do, I've take this number that's almost 4 times 10 to the negative 14th, and I multiply it by 9.5. So that times 9.5 equals, okay, and it gives me still a pretty small number, maybe a little bit bigger. And then I'm going to divide it by this 100.8. So divided by 100.8 equals, and it's still a really, really small number. I'm going to